filtration in all the ways. Interaction, only 20 minutes left, and we'll begin the lecture. We'll do as much as we can in this lecture and then we'll stop. Okay? So please be careful. I need your concentration. Now our journey starts in the tubules. We are done with the glomerulus, filtration, all the aspects. Forces, determinants, factors, regulation, everything is done about the GFR. Okay? GFR is the most important discussion, and we have done it, alhamdulillah. So our first 3 lectures were based on the GFR. Did you see that? Now we are starting our journey into the tubules. The fluid is now filtered, and now it is ready for its journey in the tubules. You know the tartib of tubules. First of all, you will begin with the proximal, and after that we'll have the loop of henle. So we'll talk about in this lecture the proximal tubule and the loop of henle. What happens inside these areas to the fluid? What kind of treatment is given to the fluid? What changes are being brought in the fluid? And from one station, proximal tubule, when it passes to the loop of henle, what are the changes which have happened in the fluid? And then passing through the different areas of the loop of henle, what changes will occur? And when it enters into the distal tubule, now you will compare that, how the fluid is different from what you saw in the proximal and the loop of henle. So station by station we will go. We are beginning the journey with the proximal tubule, the most important area of the tubule, the largest area, the largest surface area for the working is available in the proximal. So the first point which we talk about proximal tubule is its surface area. Most extensive surface area, very, very authentic and respectable area, and the major function of your tubules is controlled by the proximal tubule. So the most important area for the working is the proximal tubule. You will see yourself, okay? Now, look at these processes and this diagram. I'm sure you are comfortable with the concept, very quick concept of the urine formation. You have initiated the process of filtration. You have gone through the process of filtration. So you know, the first process for the urine formation is you need filtration. Okay. After filtration, definitely something else will happen. Now in the tubules, okay. Naturally, the fluid which is filtered is in cathedral amount. Okay, 125 ml per minute. Will you allow this whole 125 ml to become urine? No. Okay. What do you think? Out of 125 ml every minute that we are filtering, okay, how much quantity will be reabsorbed and how much quantity will become urine? What is your idea?
99 absorbed.
99 absorbed. Abdurrahim, if you are saying 99% absorbed, and if you change it into the value mLs out of 125 ml, taqriban how much will be reabsorbed?
124.
120? 24. Okay, great. Okay, yeah. more than 123, but not even 121 or 122, 124. Yani, every minute, how much fluid is reabsorbed? 124. And how much fluid is becoming urine? Okay, remember that's very simple thing. Urine formation, 1 ml per minute. Now if you calculate it in 1 hour and then you calculate it in 24 hours, you will see, okay, the urine quantity becomes about वाहिद liter or वाहिद उनुस liter, तकरीबन 1.5 liters, even 1 ml per minute, okay? But don't go more than 1 ml per minute. If you're making it 2 ml per minute, it means you are passing 3 to 4 liters of the fluid every day in urine. So, in 1 minute, average quantity is about 1 ml, and that is enough. Even less than 1 ml would be enough, okay? So, look at the figure. More than 99% of the fluid filtered is reabsorbed, and less than, only few points really, less than 0.5% is passing as the urine. Okay? So first thing that you keep in mind. After reabsorption, okay, the fluid is passing, which is not reabsorbed, that should become urine. Okay, simply it will pass out. But sometimes there is a process and few things are also coming into the lumen, not from the filtration, but from the sides of the cells, tubules, okay? Peritubular capillaries or vasa recta, or the cells of the tubules, they release few things into the tubule, into the filtrate. What is this process known as? Secretion. Okay, so it means there is one more process which is module, and that is secretion. So process 1 is filtration. Okay, process 2 is reabsorption. Little, but there is. Process 3 is secretion. And after a total calculation of 3 things, filtration, reabsorption, and secretion, the final thing which is going out is excretion or the urine. Okay, so it's a final result of all these 3 processes. Did you get that? Yeah. Okay. Alright. You know the meaning of reabsorption. Okay? How do you define reabsorption? Okay? Yes.
From lumen to blood.
Very nice, sir. Thank you very much. From the lumen to blood. This is it, okay? From lumen you are taking something into the blood, back into the blood. This is called reabsorption. What will be secretion?
From blood to lumen.
From blood to the lumen. Okay? But if I say, can there be another form of secretion from blood to lumen? Very good. Perfect answer. One more answer.
From cell
to lumen also. Sometimes a new thing is produced by the cell, not coming from blood. New thing, jadid thing is produced by the cell, and maybe that is also going as a secretion. Very nice. Okay. So the concept is very clear. Reabsorption is going back into the blood, and from the blood or from the cell, if it's coming into the lumen, it is known as secretion. Okay. All right. Okay. Reabsorption is very specific process, and it's a very big process because major amount of the fluid is reabsorbed, and you save very important things for the body, and you take back most of the things. You will see. Only the metabolites or the base products are not reabsorbed or minimally reabsorbed, but the rest is reabsorbed in a large amount. Okay? So, the total filtration in 1 day is about 180 liters. Now I am considering in 1 day, not in 1 minute. 1 minute is 125 ml, you know that, okay, GFR. But if I change it to 1 day value, big value, it is about 180 liters that is filtered. We filter how much? 180 liters. But we only form a little amount of urine, 1.5 liters of urine only, okay, in Wahid Yom. If you calculate 4 times, 5 times, 6 times we pass urine, if we pass urine like this, if we calculate the total urine, it is only up to about 1.5 liters with the average intake, not more than that really. Maybe less, maybe the same value. If 1.5 is urine and 180 is average total filtration, how much are you reabsorbing? 1.5 is passing and 180 is filtered. How much are you getting back into the body? 178.5. Only 1 liter is going, the remaining is coming back, isn't it? So 178.5 is reabsorbed and only 1.5 per day is urine. Are we clear? Okay. Secretion, we know the meaning of secretion. I am not staying here. Secretion is also a very important phenomenon because secretion helps in regulation of many substances. Some of the substances which are not filtered, they come from another route. Some of the substances which are produced by the cells and the cells want to remove them, they are also secreted. Some substances produced by the...
Excuse me, can I take a cake of the car from my friend?
Can you call your friend here? Outside.
Does it?
Quickly. Okay, so secretion is for the removal of some substances from another route. Okay. Second thing, secretion is giving you some new substances into the lumen. Sometimes for the hydrogen ions which are released and they are helping in the buffering and they have some other functions. Okay. Some other special substances are secreted and some drugs are secreted because you want to get rid of those drugs. Some drugs are not filtered from the glomerulus. They come from another route, from the side way. They come and they are secreted. Okay? So secretion has its own value. We have a valuable secretion coming. This is about the importance of secretion. Okay. Very quickly, now we are focusing the transport mechanisms. In a couple of minutes we'll talk about the basic discussion of the transport because this is very important to recall. You did transport mechanisms only in your foundation module and then you didn't revise them properly. Okay? You still have those in mind, I'm sure, but we need a refresher actually. Okay, for the transport mechanisms, the proximal tubules are using almost all transport mechanisms. Okay? If you see the transport mechanisms, I'm sure you know the meaning of the passive and active. Okay?
Yes.
Can you give example of passive? Okay. Example. What is that process called? From high concentration to low concentration. Osmosis. Osmosis of what? If I say sodium is present here, high concentration, and sodium is low concentration, is it osmosis of sodium?
No, or fluid.
Fluid. If I say an oil is present there and a low concentration of oil is present there, the movement of oil from high concentration to low concentration, is it osmosis?
No, water.
So you are coming back to water. Okay? So when you are saying osmosis, you are specifically looking at
Water.
only the water. Okay? Don't talk about other substances. Right? Osmosis from high to low concentration. What about other substances? If sodium wants to go from high to low concentration, if potassium wants to go from high to low concentration, if anything wants to go from high to low concentration, gradient. What do you call that process as? Diffusion. It is transport. It's a passive transport from high to low. But it is diffusion. Okay? So from high to low, you have diffusion. Diffusion may be divided into the diffusion of water, which you specifically call, and diffusion of other substances. It's diffusion, passive diffusion. Okay? It can be for the gases, high concentration of a gas from one side, for lipid soluble substances, for water soluble substances, anything from high to low concentration, it is diffusion. And why it is passive? Because it is not using any active form of energy or ATP, a direct or indirect form of energy. It's using its own gradient basically from high to low. This is the source. Okay? Good. So many types of diffusion you will say. If a diffusion is occurring, okay, without any help, molecules are moving automatically from high to low concentration. What type of diffusion will you call? Facilitated. You are not facilitating it by anything. Passive. Okay, it's passive because you are not using energy. But what kind of passive is this? Simple diffusion. Simple means it does not need any help. Okay, I don't want you to take me like this and leave me there. Okay, I say, leave me. I'll go myself. Okay, this is from high to low concentration. If anything is moving without any help, this is simple diffusion. But if I have a high concentration here, but still I say, no, I'm not walking like this, okay? I'll sit on this car and I will drive this car and then I'll go from there. I'm idle situation here, but I'm sitting in a car and then the car is taking me there. What is that? This is facilitated. I'm using a carrier. Facilitation. By Sayyara I'm moving, okay? By a shuttle service I'm moving, isn't it? Okay? And if I'm moving alone by myself, this is simple diffusion. Simple diffusion does not require any carrier. Facilitated does. Okay? We know. This is about diffusion. Is facilitated diffusion a passive diffusion? Yes or no? Yes, it is, because it is not using any form high to low. Okay? Alright. Give me a second. Hello? Ji Assalamu alaikum. Wa alaikum assalam.